So we've talked about prime numbers and composite numbers, but let's look a little more into what it means to be a composite number, and this will tell us about factoring. So I say a composite number is composed of prime numbers. What does it mean to be composed of prime numbers? Well, it's really a question about factoring. So let's look at the number 24. Now, I'm going to draw 24 kind of at the top, because what I'm going to do is I'm going to draw two lines coming from it. Like the top of a tree, it has this top part. And below it, I'm going to write down two pairs that divide 24. For example, 24 can be divided by 2, and you'll get 12. So just like 24 can be divided by 2 to get 12, you could also say that 24 can be divided by 12 to get 2. So it's kind of saying the same thing. Now that I've drawn this first stem of the tree, or branch of the tree, or whatever you want to call it, 2 is a prime number. I'm going to circle it and call it the end of that line. But 12 isn't prime, so I can do another 2 from it. 12 is a composite number, and it's a composite number composed of, let's say 2 and 6. Now it doesn't matter if you pick 2 and 6, or 3 and 4, you'll get the same answer in the end. Anyway, 2 is a prime number, so I stopped that train there. And 6 is a composite number, and 6 is made up of 2 and 3, and those are both prime numbers. So what does this tell us? We've gotten to the end of the tree, and we know that 24 is equal to 2 times 2 times 2 times 3. This is called the prime factorization. It's a prime factorization because all of these numbers are prime. Usually it's not written like this because this will take a very long time. For example, if you tried doing 64, the prime factorization would look like, and that just looks like a mess. So there's an easier way of doing things. So here I see 3 2's. What that means is instead of saying 2 times 2 times 2, I can instead say 2 cubed, or 2 to the power of 3. And of course I still have the times 3 on the end. So 3 is what we call an exponent. 2 is being raised to the exponent or power of 3. So we've just factored 24 into 2 cubed and 3. It's the prime factorization of 24. Now let's pick another number. I'll say 36. So 36, let's divide it by 2 to begin with. I'll get 18. And the same thing the other way around, 36 divided by 18 is 2. 2 is a prime number, so that's the end of that. And 18, I can also divide 18 by 2. And I'll get 9. 2 is a prime number, so I'll stop that there. 9 is composed of 3 times 3. So there I have that. And now the prime factorization for 36 is 2 times 2 times 3 times 3. Or, using exponents, 2 times 2 times 3 times 3 is 2 squared times 3 squared. Like so. Once you've found the prime factorization of two numbers, you can easily find their greatest common factor. The greatest common factor is some number that it can be multiplied by another number to get 36, and it can also be multiplied by another number to get 24, but it's the biggest one of those numbers. We can find it by looking at the prime factorization. So we first look at what they have in common. They both have 2's and they both have 3's. But 36 only has 2 squared, whereas 24 has 2 cubed. What this means is we have to pick the smaller one because it has to be what they have in common. And because 2 cubed is just 2 squared times 2, that means they do have the 2 squared in common. So we have 2 squared here. And as for the 3's, well, the biggest one they have in common is just 3, because this is like 3 to the first power. So there I have 3. So 2 squared and 3 is the biggest thing they have in common. And if I multiply those together, that's the same thing as 4 times 3, or 12. So 12 is the greatest common factor of 24 and 36. Also, it's worth noting that you can factor a negative number. A negative number just factors out with -1 and that number. And you leave -1 be and start your work on the rest of it.